Can I start?
Yep.
All right.
Please start with you.
All right. So my application was the healthcare letter assistant. The problem was that a lot of clinics face administrative or overload in the healthcare industry. They have to write cleric reminder letters, appeal letters, referral letters, and these letters take a lot of time to write. And they have to be professional. They have to maintain a medical tone, professional tone, and they have to be patient specific and medically accurate. And a lot of clinics, they lack the time to meet these requirements in letters and even the support to write these letters. And that also, this time delay can lead to delays in support and stuff in this industry. So the solution is an application which can do all of that in an instant almost. The goals are obviously to save time. Instead of spending hours on it, you can spend about a few seconds, and it's going to get it out for you. And also, you have to maintain the tone. It can't just be a letter like that doesn't meet those requirements. And also, overall, it's just the goal is to simplify the task of writing these letters. So the tech stack uses, for the graphical user interface, it uses Streamlit. It's interactive, it's easy to learn, and it's easy to implement. For the backend, it uses an OpenAI API, Grok API. It uses the Llama 3.8B model. It's fast and it's free to use. And for security, the program needs a place to store the API key. So the API key is stored in a .env file so that nobody outside of the virtual environment that the project is running through can access it. And the language is Python. The steps to use it, basically the user can first select the letter type. There's the 3 letter types, the referral, appeal, and reminder letters. And they can select whether they want it to be formal or informal. It's just 2 radio buttons. They choose one of them. And then they can input their information, name, sender, recipient, all that. And then what the program calls Grok API, it basically calls a method with a selected prompt based on whatever the user inputted, and then it relays that prompt over to the API, and then it retrieves the output from the API, and then that's what is put out in the output, and then the user can either highlight the text in the output, copy it to the clipboard. The application shows instructions on how to do that, or they could download it as a .txt file with a button. So I could do a little demo of this in a video. Skip ahead a bit. So that's the output. And then I did one informal letter. Right. So key features of this, there's a tone selection you can select from formal or informal, and that really helps because if you if you are focusing on that medical tone and accuracy, you can select the formal option. But if that's not a concern, you can select the informal option. And then this obviously adapts to different roles. It could be clinic staff, it can be doctors, etc. And the responses are fast. It gives you an output within 5 to 10 seconds, and is via the Grok API, ultra low latency. And then it's simple and easily usable. The users don't have to be trained on how to use it. They can just see the input boxes. They can figure out what's the input and then just generate the letter, and they'll have the letter right in front of them. And their data isn't stored. That should be self-explanatory. And then the program itself is flexible enough that you could, in the future, integrate encryption and user authentication. You could have accounts, and that brings us to the next final slide. For the evaluation, it is efficient. Most of the goals have been met, and they maintain that tone whenever you select the formal option. The one thing I would have improved, if I had more time, was fix up the prompts a little bit to remove placeholders that had brackets in them, or placeholders that were surrounded by brackets, because those did appear in the letters, and I feel like it would be a little bit better if they didn't have them. And then for future improvements, I want to have an option that the user can select a language from a language drop-down menu. If they aren't good in English, if they don't speak English, they can just choose any language they want, and then the letter can be generated in that language. I would also like to integrate manual editing of the output, so the user can generate the output and then they could edit it and then download that edited version or copy that edited version. As I said before, I would also like to integrate user accounts and logging. They could log in, and maybe their past letters, they could be stored within their account. And also email integration, they could input an email, and they could automatically send that letter to whichever email they want to send it to. And finally, template and tone personalization, they could have even more control over the template and the tone, rather than whatever options there are right now. And that's it. I can go to the GitHub repository right now. This just has the demo video that I had in the PowerPoint. This is just an example file. This is where they can put their API key. And then I'm using the MIT license. The README file has features. They can view the website over here, view the demo, and it shows how to install it on their system, and contact info. Here's the program, and this text file is basically just what needs to be installed via the terminal. But yeah, is that enough?
Yes, good job, Suhaan.
Right.
Did well. Yeah, thank you.
Thank you.
And next, who's gonna go?
I'll go next.
Yeah, okay. Yeah, please introduce yourself and tell about your project before starting.
Yeah, just let me get the screen share
Yeah.
going.
Yeah, thank you.
All right, my name's Yaozhou. This is the SciEncephalon AI internship, and my mentor was Miss Sneha. And I use AI inferencing to summarize clinical notes. All right, so this is the project overview. The background is that clinical notes are extremely detailed and often very, very long. And doctors have to read them to get a grasp of previous patients and when they come in. And the problem is that, they're very long. So the goal is to create a summary that's fast, but also accurate, and that can produce short paragraph summary in seconds. And the result is that I built a Streamlit app that allows healthcare professionals to summarize clinical notes with an 85% precision, and results come in usually 2 to 3 seconds. All right, and here is the data I used. Synthetic clinical notes were used because there were no better options. And And it came in the form of a note column and a encounter data column. The note column had the long clinical note, and the encounter data gave you a brief description of the patient that came in. And for the large language model I used Llama 3B, as it provides the largest amount of context tokens. And context is very important in this case because clinical notes are very long, and you're going to need a lot of context to understand the entire patient history. And the ideal temperature I found was a low temperature of 0 to 0.5 because clinical notes and the summaries have to be very accurate. So a low temperature is ideal for summarization. And the output tokens, a good max token output of around 300 to 500 ensures that summaries are short and it doesn't slow down the systems. All right, and for the prompting, I tested a bunch of prompts and I found the best result was with a few-shot prompting. And this is where you give your large language model an example input and output, and it pretty much follows this little blueprint it gives you. And it gives you high accuracy, and it aligns with output expectations, and it's very consistent. All right, and for the model validation, I used the Distill BERT score, and the BERT score metric is better than other metrics as it kind of uses an AI to validate another AI, and it really takes into the meaning of a text rather than just measuring the actual words itself. And with this BERT score metric, I got 3 different scores. I got a precision of 0.85, a recall of 0.72, and a F1 score of 0.78. And this is pretty good because, as you can recall from the sample data, usually when you do BERT scores, you want to compare the final result. So in this case, the summary with a sample summary, the reference summary. But in this case, we didn't have no reference summary, so I just compared the AI summary to the actual medical note. And I think this is pretty good. All right, and the next step is to get sample summarizations in our data set, so that way we can further get a higher BERT score here that's more accurate, and test other LLMs and gather human validation. And next up will be a live demo. Okay. As you can see, here's a web app. It's pretty simple. You first upload your database here. In this case, I'm going to validation database. Okay, internet's a little slow. 1 second, anytime now. Oh, I think it's because of screen sharing. Anyway, just wait for it to load. Any moment now.
So meanwhile, Yao, can you go back to the presentation?
Yeah, 1 second. Let me just. Yep.
Yeah. So you just mentioned the model validation, right? And you mentioned that there's no ground truth summary.
Yes.
Right. So what you can do is you just prepare your own summary and you can validate that. That's one thing. And the second thing is nowadays there are a lot of valid use cases wherein another model validates another AI model. So you can do that one as well. So one, I mean, as you have used Llama 3B model, you can as well use maybe something like the Mistral, or I don't know if I can't just recollect as of now, but other than Llama, you can use a different model like GBT or something like that. So you can use another AI model or LLM to validate a different LLM what you're using. So you can do that as well.
Wait, so from what I understand is that like the BERT score thing uses an AI model already, right? But that's to validate like 2 summaries, right? So what you're saying is to use another AI model to create the ground truth summary and then use this BERT model
That's right.
to validate. Yeah. Okay, got it. Okay. take that into account.
So nowadays it's like using different agents. I mean, they call it as different agents, and use different AI models to validate different AI models, like more autonomous way rather than human putting effort on validating this thing.
Got it. Okay. And back to the demo. Okay. Now you just click. So now that I've uploaded the sample clinical database, you just click upload database, and I have unique patient ID is generated for each patient. In this case, I went with a temperature of 0.1 because it allows the model to get creative, but also stick to the truth. Turn the tokens up to 300 to make sure nothing's cut out. Let's just go with this dude right here. And click generate summary, and then 2 to 3 seconds, you see the patient clinical note. In this case, the patient name is Amy, and the summary is right here. It gives you a 4 to 5 sentence paragraph summary. It's pretty accurate, and that's everything. And oh yes, and here's what I learned. I learned some key terms such as AI inferencing, temperature, tokens, contexts, parameters. I also learned how to effectively prompt a large language model. I also learned how to design a efficient web app. And I also learned how to effectively validate models in the real world. And thank you.
Thank you. Yeah.
Yep.
Okay. Next.
I can go next.
Oh.
Give me 1 second. Okay. So, my name is Anna Hoen. I did my project of the patient education generator. So, the main issue with medical information is that it's very complex and it's full of jargon that people don't understand. It's not personalized. And so a lot of patients and caregivers struggle to understand it. So, and also clear empathetic education improves understanding, confidence, and treatment outcomes for patients. So having an app that can explain these conditions in a way that is personalized and simple will help patients really understand and be able to follow the steps to improve the diagnoses. So this app was designed for patients of all ages to help them understand their conditions, but it can also help caregivers and healthcare workers to help their patients or the people they're caring for really understand and be able to better follow their treatment plans. So I built a Streamlit web app that generates simple explanations using AI. It personalizes output with patient name, age, lifestyle, etc., and then reads the content aloud via text-to-speech and offers examples for demonstration. So this is an example of a prompt, and then the response with text-to-speech. That it's like talking directly to the patient, and it's making sure to include stuff about their interests and to help them get engaged in their in the response. So I chose Ollama 3, specifically 8B, as my model because it's open source, it's reliable, it's lightweight, it has fast generation, and has balanced reasoning. Compared to other models, it is more tested, more reliable, and it's capable of better nuanced reasoning. And so, oops. So I had originally used Ollama to run my model locally, and it worked well for development, but it wasn't suitable for deployment because Ollama it can really only run locally. And so to make it accessible online, I switched to Grok, which is a platform that runs language models in the cloud. And it supports the same models and prompts as Ollama, but it has much faster generation speed, which makes it much more responsible and usable in real time. So down here is a example of how the AI gets from user input to generate content. So it takes in the user input. In the code, it is placed into the prompt, and then the prompt is sent to the Grok API, which calls Llama 3, and then Llama 3 turns the prompt into generated content. So to get these clear and personalized responses, I designed a specific prompting strategy. The base prompt uses the patient's name, their age, and the medical condition, and then from there, users can optionally add personalization for their interests, lifestyle, and specific concerns, but it's not needed to get an output. It's just a additional thing that can make the AI explanation feel more relevant and personal. And then I've also instructed the AI to be clear, age appropriate, and supportive to make sure that it's not giving strange suggestions that they don't make sense in the explanation. And then it also includes a rewrite feature to reformat the output if the user doesn't like how the generation came out, if they want it to be shorter, in bullet points, friendlier, or more detailed. And then I tested multiple different wordings to make sure that the AI was simple, empathetic, and clear all at the same time, and it wasn't giving too little or too much information. So here is the UI for my app. There is the input form with the name, the age, and the select box for a condition. And then there's the toggle for personal details that allows, so when you click that, it allows you to enter more details. And then there's a toggle for caregiver mode to talk specifically to a caregiver instead of talking to a patient for younger patients or patients who are not able to use the app. And then there's also a toggle for text-to-speech. And then there's the clear input button, which clears all the inputs automatically instead of the user having to go back and clear everything manually. And then there's a generate button that generates the context. And then once you generate, there's also a clear response button, which clears the generated response instead of you having to scroll back up. And then there's also the rewrite option where you can choose, you can choose if you want it to be shorter, like how you want to rewrite it. And there's also at the bottom an example section with expandable boxes for different examples. So in the future, I have multiple things that could be improved on. There could be a print or export to PDF option for users to save their generated content. We could switch to a better text-to-speech model that feels more natural sounding and is faster, because Google text-to-speech is currently generates a little slowly and is also a little monotone and sometimes doesn't read words right. And then for personalization, we can add multilingual support for users who don't speak English and need everything to be translated. And then we can also expand the conditions list instead of having it, because right now I have an other option in addition to my 5 conditions, but that could be expanded. And then for user interaction, we could collect feedback to improve the future generated content, and we could also have a chatbot for follow-up questions a user may have after they read their explanations. So over the course of this project, I learned to work with a range of tools and technologies. I learned Streamlit, Grok, GitHub, and then for AI, I learned prompt engineering. I learned how to use Google TTS, and I learned how to use the Llama model. And then I coded everything in Python and using VS Code as my coding platform. So I learned a lot more about Python and VS Code. And then, oh God, sorry. And then for my soft skills, I built upon my time management, problem solving, and my adaptability as I worked through the challenges that this project gave me. And so that's it. And I'm going to switch to the live demo. Okay, so here is my app. So I'm going to put in just a test case. So you can add toggles here. And then you can enable text to speech. And so, oh, hold on, sorry. So yeah, it makes sure you fill in all the fields before it allows you to generate content to make sure there's no errors. Yeah, currently audio generation takes a little bit. So it gives you audio, and then it'll tell you like what the condition is, what are the symptoms, what are the causes, how do you treat the condition, and then it gives you tips on what you can do to manage your condition with your interests in like your life. And then also it talks about like your concern and is just really supportive overall. And then you've got here, you can choose rewriting. So like if I wanted it, let's say I want it to be shorter, you'd rewrite the explanation and it gives you a shorter version of the explanation. And at the bottom, it has a disclaimer that it's AI generated and not a substitute for medical advice in case it gives an incorrect response. And then down here, I have my expandable boxes for the prompt and response, the 3 examples. And then you can always clear the inputs, and you can also clear the generated response. That's it.
Did you evaluate the model? Did you evaluate the model?
Oh, no, I did not.
Okay.
Thank you, Anna. Who's next? Prateek?
Yeah, I can go next. Can you see my screen?
Yes.
So my name is Prateek. My mentor was Dr. Neelima, and I did the discharge summary rewriter. So the overview of the problem is that discharge notes are complicated and hard to read medical notes. These are written directly by doctors and professionals who know exactly all the medical jargon and all that information, which is really hard and complicated for normal people to read. The goal was to rewrite these clinical discharge notes in an easy and a simple to understand way. So the sample data we used was synthetic or AI generated medical notes. It came in a comma separated values file, and it's split up into the discharge summary itself, or the notes, and the patient names. So the tech stack of the project is that it used Streamlit as a web app interface and user input so what the user actually sees and interacts with. It uses Ollama for the local large language model for summarization, so that the prompt that the user, the prompt inputted into Ollama has the summarization output. And the project uses Python for the core application logic. So how it works is that the Streamlit works as the input, which is then output into Python for the logic, and the prompt, which is sent to Ollama and sent back to Streamlit for the user to actually see. This is how the application looks. It has a drop-down for the comprehension level, so you can choose what grade you are in, word count, so you can select how long you want your words to be, or how long you want your output to be. And you can include explanation of medical terms. The big black box is for the input of the discharge notes, and the submit button allows you to submit to the model. The key features of the project are the Ollama 5.3 mini large language model. I chose this model because it has specialization and summarization and has the best outputs. The project includes the grade level and word count estimator, so you can change the output to however you want. And it also includes friendly and simplified language output for the best possible responses. This is the prompt that we use. As you can see, it has a strict rule sets that the AI must follow. So it has similar outputs, which also allows it to avoid medical jargon so the text doesn't overcomplicate. You can see I also include examples for how the input and output should be so that the AI doesn't mess up the output. The next steps are to create a more advanced user interface, maybe a login to see past model, to see past notes, test real discharge notes that were used in hospitals, maybe alternate learning models such as ChatGPT or Gemini, and also include export features so you can save in the future. During this thing, I learned how to use Streamlit and Ollama and how to use them together, how they complement each other. I also learned how to do prompt generation and creation and how to edit and improve them. And I also learned data frame modification. And that's the presentation. So now I'll go to the live demo. So this is the rewriter itself. It has a comprehension level generation, so you can choose the summarization details. It has a word count selector, so you can choose how many words are in the output. And here is the medical term explanation checkbox, so it includes or excludes medical jargon. And then here's the actual discharge notes we gathered. This is one of the test notes from the AI generated. And here is the actual output. So this is the actual summarization itself. And that's it.
Thank you, Prateek. Next is Shreyas, right?
Yep.
Okay.
Let me present. Right. I'm Shreyas Sindhaval, and I made the medical question answering chatbot, or MedQuad. I'm a mentor with Shanmukh. So this is just what we're going to go over today. We have the overview of the data, what we did to get the data, implementing the model, the UI, and future enhancements, and the conclusion. All right. So for the project overview, the objective was to make a AI-powered medical question answering chatbot that gives users accurate information based on medical data that was accurately sourced. So to do that, we integrated FAISS, which is a query retrieval method for a database, and an LLM for language generation. And it aims to ensure contextual relevance and reduce hallucinations, which basically is where the LLM just makes up data so that the users get a trustworthy response. So for the importance of addressing medical queries, we wanted to allow users to have accurate medical information in their hands and take their healthcare into their own hands, just rare awareness all around, so they can take action without relying on, the Google or just doctors in general, because of the costs that come with doctors, just to, make sure that you're aware of your own health without doing like an extreme number of checkups or anything like that. And for impact on patient care, obviously we're improving the patient access to necessary information and making sure that patient satisfaction is maxed. So for the actual data, the data is like over 47,000 question and answer pairs from 12 NIH websites. And for query searching, we index with FAISS for retrieval, where we converted the data into FAISS and pickle formats to optimize storage and retrieval efficiency for actual querying with scripts. And we also included the script so that the users could utilize it to expand the dataset on their own and improve responses, since more data makes the actual bot more accessible for more people. And for answering, the bot actually queries questions given and finds multiple answers in the dataset, which we provide through the prompt as context to provide for accurate answers. For the model architecture, obviously we have the data, which was from the MedQuad XML dataset, and it would had over 12 medical categories, which we all fed into the database. And all questions are embedded and stored in the index for a similarity search. And then we just search for relevant questions with the index and retrieve the corresponding answers, which are all fed into the Grok-hosted LLM through the prompt. And the prompt tells the bot to strictly stick to the context to make sure that the hallucination rate is minimized and that the responses are reliable. So the Llama 370B model was chosen in particular because when compared to like other models, it's more open weight and easier to integrate. And it also provides similar quality responses for tasks and has lower latency. So it's faster and it has a lower rate of hallucination when answering when I compared it to other models or I used other models. So this was by far the most reliable, even if it wasn't the fastest. All right, so for user experience and UI overview, we have the a settings sidebar. So users can ask medical questions through the chat layout and get the answers from a verified medical data set. And this is the sidebar. It allows users to customize the behavior of the model itself with toggles for temperature, source visibility, response length, and answer detail level. And I made everything sliders because that just felt the most intuitive for the user to me. We also have additional features like the conversation history, reset button, and allowing the user to download the transcript for increased usability. And for my conclusion, I just included an overview again of the entire thing. So use LLMs and a verified data set to make sure that the user had accurate answers. User-focused design, everything's intuitive with sliders. The scalable foundation is where I included the prompt, or the script to make the actual face index or expand it at least. So that way the model itself could be more accessible in the future if a user's decided to add on to it and verify it themselves. And for future enhancements, I put plans to integrate multilingual and voice support. So having the model speak in other languages other than English to make it more accessible for more people, and voice support in a way that didn't increase the latency of the model to make it actually usable, since integrating voice support can lead to increased response time, which is not something we wanted. So a way to integrate voice support without increasing latency. And yeah, thank you. I have all my links, and I'm going to go to the GitHub now. So I'll have my GitHub and my README with steps to follow for the for index medquad. This is the script that I use to make the actual data set, and this is the app that actually runs. That's actually running on Streamlit right now. Obviously, my sidebar, you can minimize it to make it not a pain to look at the entire time. Obviously, it has everything we talked about before: response style, entries, max response like temperature, showing the file that actually got the responses to make sure that the user can verify it. and being able to reset the conversation. And yeah, it does take time. However, it is a bit slow due to having to index everything. As you can see, it included all of this stuff because the response length was high and the response style was detailed. And you can download conversation transcript as I stated before. And yeah, I think that's it. Anything else? Like any questions?
No, Shreyas, everything's good. Anything to add, Venkat and Neelima?
No.
Okay. Yep. Thank you, Shreyas. You did a good job. So, and everyone, please share your presentation, GitHub, and documentation to to all the mentors. I will share you all their emails in the chat box. Please let me share it.
The document, like the PDF document, you said we just email it to you?
Yeah, I'm pasting all the mentors email. Just give me a second. Okay. So I pasted all those emails in the chat box. You can all share your presentation, GitHub, and the project report. And this recording will be shared in the YouTube. Once it's up in the YouTube, we'll share you those links. Yeah. Anything to add, Neelima or Venkat?
I got a question.
Mm-hmm.
Is this our last meeting?
Yes, this will be our last meeting.
Got it.
Let me see. So it shows like we have meeting on 10, but I think this will be our last meeting. So yeah.
All right. Oh, I just emailed everything.
Okay. Yeah, thank you all for this internship. Hope you all learned something new in this internship. Yeah, if you have any questions, please ask.
Thank you so much.
All right, thank you. Have a good day.
Yeah,
Thanks
thank
a
you.
lot.
Thank you very much.
Thank you. Thank you, guys.
Goodbye.
Bye.